Python contributor from version 1.1, has a great experience also in PostgreSQL, about 20 years, right? Yeah, and yeah, thank you. Go.
Hello, is it better? Very good. So, my name is Krosing, here is my email and also Skype. If it's so interesting you want to later get in touch. And yes, I'm Python user since about version 1. I think it was beginning of 90s, maybe even earlier, probably earlier, end of 80s. Also, I have been using PostgreSQL since before it acquired SQL. It used a language called Quell, or for short for query language, or PostQuell. Quell was the one for Ingress, and when Michael Stonebreaker, who is the brains behind the first versions of Postgres, came back to university, then he set up to make a really extendable language, and then it was called PostQuell. And yes, I'm a small-time hacker and contribute to both Python and Postgres. I have made Pascal strings, module for structure, support for structure module, and a few modernizations to XML support when it was a new thing. From my professional experience, the biggest databases, so my first contacts with really big databases were from Skype, where I was the first DBA and for some time also the first and only database architect. And now I have been, since Skype was acquired first time by eBay, I have been independent or kind of independent consultant in a larger group of PostgreSQL specialists called Second Quadrant. Second Quadrant is a group of companies with worldwide reach. We do all kinds of stuff, but among others, we also, many of us know Python quite well. And I also am a technical advisor to the investment company by the Skype founding engineers from Estonia. When Skype was sold first to eBay, they also got a little money and put about 100 million euros into their venture capital firm. And now they are investing it in small chunks from a few tens to a few hundreds of euros to promising startups. And if they have some interesting technical challenges, then they ask me to help. And I've also written some books. Written some books on Postgres. The first one is together with Simon Weeks, who is I would say one of the main contributors to PostgreSQL, and also he's the head of, or not head, but the main guy who were the brains behind creating the Second Quadrant company. And the other is PostgreSQL server programming, which should give you basics of getting started with programming in PostgreSQL server. It touches all the main things you need to know to get started. But it's only, I think, 300 or 400 pages, so you just get the beginnings. But at least you know where to look further. This should be out by now. The final chapters were turned in about a month ago, so should be available. And it has also chapters on things like plpython. So, what is Python? again, like yesterday, you probably know what the Python is. It's a dynamic, flexible, object-oriented programming language. The one I am talking about here is C Python, which means that it also is interpreted. It has good introspection, has libraries for anything you would like to do. And but there are more. That Python is also easy to extend, which means that you can write C extensions. And it's also easy to use as an extension in other languages. And the embedded language plpython, which of Postgres, does both. First, it serves as a computing engine if you use it inside Postgres. It is a full Python interpreter wrapped in a C interface and then made usable through system tables to Postgres system. But it also goes the other way, which means that it can make calls back into Postgres and make queries and other such stuff. So Postgres, again, is the most hackable relational database, at least of the serious ones. And it is from the very beginning, it is built for extensibility. It stores different object types. Everything is defined in system tables, which means that not only the structure of tables, the composition, what types, what fields are there, but it also has lots of other objects in addition to tables. It has schemas, views, functions, operators. And the ones we are going to touch in this talk are user-defined languages. So if you have an idea for a language, or you happen to have a favorite language which you want to use inside Postgres, then you just write a small wrapper function, or 2 or 3, depending on exactly what you want to do. And then you can use it from Postgres to define new functions. And it has also internal interface called server programming interface for making calls back to the running server. So you don't have to connect to server as you do from client side. Even though in most of its capabilities, it's very similar to what you would get if you just connect to the database. So what is an embedded language? So all languages or all functions in Postgres are written in something. So mostly they are written in C, being the language that Postgres itself is written in. And when you look at the definitions in PG_procedure table, then you see that they are defined as C or internal. There are also 2 interpreted languages available out of the box. They are SQL, which basically lets you bundle together a set of SQL calls, SQL statements, either selects, inserts, deletes, and then they just get executed together when you call the function with some possibility to pass parameters. And you also have a language, procedural language, PGSQL, which is SQL with some procedural infrastructure around them. You can make loops, you can make if constructs, you can assign variables and so on. And the core group, Postgres core developers also maintain 3 installable PL languages, Python, TCL, and Perl. 2 of these have both untrusted and trusted versions. Python has only untrusted version. Untrusted doesn't mean that we don't think that you should use it. it is untrusted in the same sense that you don't leave a sharp knife lying around on a table so that somebody might hurt himself. Which means that also in Postgres, only super users can use untrusted PL languages to create functions. Once the functions are created, they are free to grant the rights to these functions to anybody. So it's not like they don't work. They work very well, and they enable you to do things that you otherwise couldn't do. And most embedded languages, as I said, wrap some language, some existing language. There are only 2 languages which are made specifically for Postgres. One is plpython, which is kind of modeled after Oracle's PL/SQL, and the other is PL/LOL code, which is made for sole purpose of showing how an embedded language is done, how you create an embedded language. And usually the embedded languages are oriented towards the end user, so they are not made for hacking internals of Postgres or for extending Postgres any further. Embedded language handler is implemented by a language handler function, which when called gets a pointer to the actual function definition, which it then looks up, compiles the function index to bytecode, and likely also caches this. It converts arguments to PostgreSQL, from PostgreSQL to the embedded language format. It calls the function it compiled in the first step with these arguments, and then it converts the return value back to PostgreSQL format and returns it to the query evaluation mechanism. And if it uses the SPI interface to make queries into the database, then it makes all this the same conversions in opposite direction. It converts, say, in case of Python, it converts from Python to Postgres objects, calls the function, calls the query, and then converts the result back to Python. So there's quite a lot of conversion going on, which also means that you wouldn't want to write small functions in PL languages. So as we said, it has almost everything defined in system tables, object structures, functions, operators, user-defined languages, and it also has types defined there. So like Python, PostgreSQL types are also just objects, even though they are special objects with their special uses. And as other objects, they are also defined in system tables. So how do you define a type in Postgres? There are many different types of types in Postgres. So you have at least these 5, which first is an enumerated type, or enum, basically a correspondence between integers and strings, a structured type, range type, array type, and then base or scalar types like integer or internet address. An enumerated type is created by this syntax. You just say, for example, if you have a special type, then you create it as an enumeration of these values. And basically this declaration just associates the names with a set of integer values. And other ways, they look like string when you query thing or input. Internally they are stored as integers, and when you are sort on these values, you get the sort order of the same sort order as in your definition. So it's not just a restricted set of strings. It has some special parameters. A composite type looks very much like a table row. Basically, it's same as a structure would be in C. You have a set of fields with names and types associated with these. This is basically, it's very much like in Python when you declare a new type class and set the value for underscore slots. So you have, but it has an extra restriction that you only can put a specific type of value in each field. Both Postgres and Python are strongly typed languages, but in Postgres the type is associated with a variable. In Postgres it's associated with a value. So there is no loose things that can be sometimes string and sometimes integer. If you have an object, it is of specific type, but in Postgres the variable defines the type. In Python it's the object itself. And composite types are very much like table definitions, and in many cases they can be interchanged. For example, if you declare a function, if you create a function in Postgres, then you can, one of the ways to say what it returns or what types it takes. What it returns is, say, it returns a type or it returns a table. Both times it means that it returns a single row of this type or matching this table. And you can also use a type directly to declare a table to store object of this type. This form is equivalent of just declaring instead of type, you could put the same values as the type definition and get exactly a similar table. Behind the scenes, actually what happens when you declare a table, then Postgres declares a similar type in the background. And all the types you define here are real data types. They can be used anywhere you can use a data type. So you can, for example, use an array of this newly defined type as a field in a table and use it as such. Even though in database literature it's often not recommended to put more than a single value in a table, or they recommend to have normalized tables. Sometimes it makes sense not to do it. So, especially as exemplified by the NoSQL movement, which nowadays carries this approach to the other end. So they can just put anything anywhere and usually don't have any structure at all, any predefined structure. And now when we select, then we get a string like this out of the table. It's not very readable, but if you don't do very deeply nested types, it's okay. And mostly it will be used by some application which understands these things. Since we have JSON support in Postgres 9.4, you can get a much nicer form out of it, something that you can directly use from your client application. You just say a row to JSON and it goes down this structure and prints out everything in a nicely usable way. Okay, these were the types that are easy to define. Now let's go to real or scalar types, which will be, after they are declared, equivalent to whatever is present in Postgres to start with, equivalent to text, date, so on. And basically it is something that is defined by a lower level. You need to have at least input and output functions, and you may have also binary input, binary output functions. Here is a sample from a prefix package that a colleague of mine wrote for doing fast matching of phone prefixes, which is, at first sight, it seems that it's something easy to do, but because prefixes can be of different lengths, doing it efficiently is sometimes a challenge. So just sample, we'll go through this now step by step. And also to make efficient use of the type, you need other things. You can teach Postgres how to use indexes for this, and so it will tie in PostgreSQL optimization mechanism. And once it is declared, then programmer doesn't need to do anything more. It will automatically be used. The most efficient ways to do queries will be chosen. So you don't need to figure out each time you use how to do query, which one is the most efficient way. So as I showed you, you can do it already in C, but and as I said, in C you can do anything. You can have very intimate access to all PostgreSQL functionality. But most PL languages only support so-called user types, or types that have full set of EO functions, index method accesses, and so on defined. And usually you are not supposed to do internal stuff from PL languages. But C-string, which as you saw is used here as input function argument, and also as return type for out. It is not a user type. You are not supposed to use it in your tables. You even can't put it in a table efficiently. But it is used internally in many places. So what is needed to make plpython able to support the input-output functions for Postgres? First, you need to add support for C-string, so that it doesn't reject it by telling just that pseudotypes are not supported. The other was more tricky. You must avoid recursion on type input, and you must support shell types. Anyway, I said 2 challenges, there were more. I initially hoped there was only one. So for C-type, it was relatively easy. C-string in Postgres is just ordinary zero-terminated string, and which means that it's very easy to work from C, and everything passed to input functions are given as C-strings to type input functions. And most input-output conversions already in plpython use C-string as intermediate format. And only the most popular ones like integer or text have direct conversions. Otherwise, for others, you just convert to text in Postgres side and then use Python types to take text and convert to internal Python representation. So supporting C-string just meant that I had to leave out half of the conversion, the part that converted to or from C-string. This one was easy. But the next one was more challenging, because if there is no special conversion format, then Postgres goes for the text representation in its PL-PGSQL goes. This is something that each language handler function must do itself. then obviously you can't use the function itself to convert from text to internal, as we are already in the function and it would just cause infinite recursion. So we need to pass this, we actually need to pass it on as a text or some other raw format. There were several ways suggested how we could do this, but in the end, I found out that we already have the identifiers of the functions available, so if you just compare that we are already in the conversion functions, then we just convert to or from text, and then that's it. The third one was that the third problem is that you have a kind of chicken and egg problem where you need the input functions to declare a type, and you need the type to declare the input functions. So Postgres has solved it by having a shell type or partially defined type, which you declare first. After that, you can use this shell type to declare the functions, and once the functions are done, then you kind of redeclare or complete the type definition. So here once this is done, you can declare C functions. You can declare plpython functions and use them as type IO function. Here are two samples. One declares a variable length function, which basically takes the text and converts it to data. And once this is done, you can use it everywhere to declare tables, to declare functions, basically anywhere you have you would use any other Postgres type. And here is one that is fixed width type. You just get a string, and then you can use struct module to convert string to text and back, and it will have 4-byte internal representation. So but there are still one more challenge. Going through Python each time is a bit slow, so you don't want to do it for very small things. You still want to do it for some stuff that is hard, that is some type that has already lots of functionality defined in Python. So you can use this for just wrapping it or making it available for Postgres. And there are some more interesting developments in Postgres for making these things run faster, like declaring transforms, which are basically independent type conversion support objects, kind of similar to casts, but specifically for using by PL languages. And also another thing is that we might make it possible for PL Python functions to have easier access to each other, which can be done by changing structures. Okay, let's just put other things that I wanted to mention that at some of them I have briefly looked, but they were just kind of wish list. So we are out of time, so do you have questions?
probably two questions in one. Which version of Python are you using, and how do you handle Unicode?
I have been developing this on 9.2, 9.3 alpha, but it's not yet in 9.3. I was a little late for latest commit fest, and so everybody was busy doing other things, but functions are against, well, patches are against 9.3. 2.7 is the one I did, but also plpython has support for Python 3. But in this part I didn't, I think I even tried to make it compatible, but I didn't test with Python 3. So it is, in Python 2 I make text objects, in Python 3 I make bytes objects. For the ones I pass for conversion functions. So it's just binary blobs in theory.
Maybe there is a bit of a lack of information on my side, but how exactly do you spin up the interpreter for Python in Postgres? Because
internally what happens now is an initialization function, which the server itself, it is the task of the handler function to spin up also the interpreter. So the first time in a session you call it, it actually loads the Python library and does the initialization. So there are kind of two different initializations. One is the initialization of the whole interpreter, which happens in the very beginning, and the next one is for each call of each function, it gets compiled to bytecode and cached. So all this is the task of the handler function.
And so is this then, is each of these calls, because it's an untrusted function, right, untrusted environment,
Yes.
Is each of these calls then run in the same thread, or is it like...
It's in the same thread, yes. It's basically in the same process space.
So I can, if I manage to crash, what happens if it crashes, right? Like, for example, I don't have like something like recursion or something else. Can it hold everything?
Basically, this Postgres has a process architecture. So each backend is its own process. So if you crash it, then you crash this process. And depending on where exactly this crashes, you also may cause the whole Postgres server to restart. If there are two different types of crashes that can happen. So it's fatal, then the postmaster or the controlling process notices it and brings down all the other backends also, because it suspects that maybe shared memory is corrupted. If you crash in some safer place, then just this backend crashes.
Hi, so it's not directly related to the PL Postgres. If you define a composite data type, can you apply indexes to it? And if you can, how do you do that?
Then you must declare your interface functions for index access methods. Basically, what is
talking about the composite types you have at
yes.
the beginning with
yes.
name comments.
Yes.
Which got encoded as JSON, basically. How do you index those?
No, I didn't. They are not encoded as JSON inside the table. But you can actually use JSON data type, and I have even run some tests and stuff on JSON data type. And if you do it in JSON, then you can have, say, plpython or plv8 functions that extract a single value, and then you can make a functional index on the JSON data type. So it can be either single index or inverted index. Inverted index is an index which can have multiple pointers to the same item. So because of Postgres native support for functional indexes, all this is really easy to do. You could just declare a function that, say, extracts a name from your JSON and then then index directly on this data type. What I was referring to before was if you want them to be automatically recognized directly without functions, then you must introduce the type to the indexing mechanism. But for just using functional indexes, you just need only the function, and then when you create the index, then you use the function.
If I have a replication environment set up, and now I want to introduce a large set of Python modules and things into it, are there any caveats with that?
Yes, you must, if you use anything that is imported, then you must just put them on both sides. What I have done is that you have a Python new function for this, where you can actually pass the whole file through, and it stores it somewhere it can access. So if you have many of them, you just push them everywhere. But you can also use all kinds of Chef or Pony or these things that just make it copied it everywhere, just like anything that lives outside Postgres. There have been some discussions about actually making Postgres, making plpython able to load modules from inside database, which would make it kind of Postgres managed thing. But currently it is not there. Any questions?
I was just thinking if I could trick plpython to load a module by doing an import loop. That was just...
This is something else I have thought about, that if the module is missing and I use it from, say, Django and push, say, a larger thing there, then by hacking into wire protocol, it should be able to define import hooks that call back to the client and get the missing modules. Yeah. It shouldn't be even hard, but it's some amount of work.
Yeah. And what about if different servers use different version of Python, and let's say one uses Python 2.7 and the other uses Python 3, and so you are hosting that as a stream of bytes, as far as I understood, right?
It shouldn't be visible outside. If you write your functions so that it compiles on both, then it should be work on both sides. Only if you use something that's not compatible, because our Postgres stores it is source code, and each time the function is first loaded in a session, it gets compiled.
Okay, so, but for example, if I use different version of Python, and on one I try to retrieve the data, and on the other I'm inserting the data, is there any possibility to have integrity error in case in one case I'm using Python 2.7 and in the other another version of Python?
You should anyway.
The first problem that comes into my mind is the problem of encoding. I mean,
yes, you must make sure that the binary format must be come out the same, or the format you convert to using these IO functions. The same is true also if you compile Postgres itself on different architectures, then the binary format on disk is different. So basically you have all the same concerns independent of what language you write the function, IO functions in.
Anybody? Okay. Thank you very much.